So basically what we're going to do today is we're going to work with, they're basically equations, but they're trig identities that we're basically going to work to manipulate them using these already kind of established identities to get like each side of the identity to be the same. Okay, so here's what those look like. They look like equations involving a bunch of trig equations, functions, and also kind of properties and identities. So what we're going to work to do is we're going to work to take one side of this equation or one side of this identity, and the reason it's an identity is because these do equal each other. We just need to figure out how. How can we show that? How can we be sure that this left side, secant of x cotangent of x equals cosecant of x? Well, the way that we're going to accomplish that is using all those identities that we had kind of at the front. So if you're watching online, so watching the video, you'll get a sheet of these identities, and we're going to reference these as we work through the lessons today. For those of you sitting in class today, you have those identities in front of you with what I just handed out. So when we're doing this, you're only going to work with one side. Okay, there are exceptions where we might work with another, both sides of the equation, but we're not going to like divide by secant of x. We're not going to work to get x by itself. So it's going to feel very different than what you know about equations so far. So the only thing I'm going to do is work with this left side, and typically we're going to stick with the more complicated side, so the side that appears to have more terms. And we're going to find ways that we can rewrite secant and cotangent to eventually get it to equal cosecant. So what we start to do is we look at our identities and ask ourselves, what are some other ways that we can write secant of x? Well, if we look at the identity sheet, I'm seeing that secant of x I can rewrite as 1 over cosine of x. So I'm going to start with that and just see where it takes me. So instead of secant of x, I'm going to call this 1 over cosine of x. And I'm going to do a similar thing with cotangent of x and find a way that I can rewrite it. So on this identity sheet, I'm seeing two different ways of how I can rewrite cotangent. I can write it as 1 over tangent of x. If I do that, I'm not really seeing any sort of algebra or anything that's telling me how I can eventually get to cosecant. But I'm also seeing that I can rewrite tangent of x, or excuse me, cotangent of x, as cosine over sine. And I'm like, if I write it as cosine of x over sine of x, maybe I can get this cosine of x to divide out. So I'm going to use that quotient identity, that cotangent of x equals cosine over sine, and rewrite cotangent as cosine of x divided by sine of x. So again, I haven't even done anything on the right side. All I'm doing is working on getting this left side to eventually equal cosecant of x. Well, right now, I have 1 divided by cosine of x. Now we're multiplying by cosine of x. So those cosine of x's divide out and go away. And now we're left over with 1 over sine of x. And 1 over sine of x, according to the reciprocal identities, is equal to cosecant of x. And that's what we're working to get this to equal. And thus we have just verified that secant of x times cotangent of x does in fact equal cosecant of x. So with these, work has to be shown. You can't just cancel things out and say, oh yeah, the left side's going to equal cosecant of x and skip all this work. Okay, the work actually needs to show up. Okay, so again, after each example, you're going to have a problem that you're going to do on your own. So if you're watching online or here today, you're going to take now 2 minutes to work through this problem that I'm not going to go over. You need to come up with the steps to verify this identity. So I'm going to give you all, I'll add a minute to this. We're going to say 3 minutes for you to work with the left side and try to get it to match up with the right side. If you're watching online, pause the video and work through it right now. Okay, so before we jump into the next identity, I just want to point out that I kind of touched on this, but the difference between solving, it says conditional equation, but basically an equation that you're used to seeing, and verifying an equation as an identity, what is the difference there? So you solve equations by working with both sides at once, adding, subtracting, multiplying, and dividing the sides by the same expression. That's what we're used to, right? If I have like 2x minus 1 equals 3, I'd add the 1, divide by 2, right? That's what you all have been used to every time you see an equation. However, when we verify an identity, we are manipulating each side of the equation independently of the other side, meaning we're not going to divide both sides by sine of x. Here, I'm not going to subtract cosine of x. We're strictly going to work with one side of the equation separate from the other. Okay, because you are familiar with solving equations where we're adding, subtracting, multiplying, dividing on both sides, it's going to feel strange to verify identities by working separately with each side of the equation. Okay, so we've got to be really mindful about how this is different than us actually solving the equation. We're not solving anything, we're just verifying these identities. So now, the next one we're going to work through is we're going to work to verify that sine of x times tangent of x plus cosine of x just simply equals secant of x. Okay, each one's going to go a little bit harder. So to me, these end up being a lot like kind of trig puzzles, where the steps and things that we're allowed to do come from your identity sheet that I showed at the beginning. Okay, see, these are all the things we're allowed to use. And we're going to use those to try to piece this together to get it to match up. A lot of times you might try something and it may not get you anywhere near where you need to go. So be willing to kind of restart. Okay, so one kind of good way to start is to change each trig function to be sines and cosines. Okay, because we can get a lot of them to divide out, like we saw in the last one, that ends up working out really nicely a lot of the time. So I'm looking at this and I see I have sine of x times tangent of x. So I'm going to leave this sine of x as is. But instead of having tangent of x, I'm going to rewrite that using that same quotient identity that we did before, but this time with tangent, and rewrite it as sine over cosine. So we're going to write this as times sine of x over cosine of x, and then we're still adding cosine of x. Okay, so the only thing I've done so far is rewrite tangent of x as sine over cosine. Well, I can do this multiplying of the fractions. That's sine of x times another sine of x, which is sine squared of x over cosine of x. And we're still adding cosine of x and trying to get it to equal secant of x. Even right now, it feels like we're kind of far away. Okay, and one thing that I don't really like about this is the fraction. So I'm wondering, is there a way that I can maybe combine these two terms and get it to be one single expression? Well, I can add terms if their denominators are the exact same. So I'm going to work to get this cosine of x to have the same denominator, being cosine, by multiplying it by cosine of x divided by cosine of x. So this is just me getting a common denominator here. And so this turns into sine squared of x plus cosine squared of x. And then all of these are now divided by cosine of x. Now that we have a common denominator, I can add these fractions just like I normally would. So sine squared plus cosine squared all over our common denominator, which is just cosine of x. And so up to this point, I've rewritten everything in terms of sine and cosine and found a way to write it as one expression. If we see these sine squareds and cosine squareds, more than likely that's going to tell us to use one of these Pythagorean identities that have all these squared terms involved with them. Okay, so I'm seeing right here that one of these Pythagorean identities, sine squared of x plus cosine squared of x, just simply equals 1. This is our entire numerator. Right now I have sine squared plus cosine squared. So I'm going to rewrite this as 1 over cosine of x. And sure enough, 1 over cosine of x is the reciprocal identity for secant of x. And thus we have just verified that sine of x tangent of x plus cosine of x actually just simply equals secant of x. Okay, so a lot more steps involved to get there. But we did get to secant of x. Yeah, question? Are they always going to be what? Correct. Yes. Yep. I'll only give you identities that will work out. So there's always going to be a way for us to get there. And again, you have to show the work. You can't just skip steps. Okay, we have to actually show everything going on here. Okay. I'm going to have you all try one in your groups. Again, the steps should be somewhat similar. So if you're watching online, you need to pause the video and work through this next identity. For those of you in here, I'm going to give you 3 minutes to work through this next identity. And then we'll do one more before we take our 5-minute break. 2. And now we're going to move on to our next identity. And this will be the last one we'll do before we take our 5-minute break. Okay, so I'm going to go through this, have you all do checkpoint 3, and then we'll take our 5-minute break, come back and do basically one more before we get to the end of class. Okay, so not only do we have to involve some of the trig identities that that will always be provided, but we're going to also involve algebraic steps that we've been working with all year. Hence, we basically did that on the last one. Algebraic steps being like finding a common denominator, adding fractions. Well, there might be times that we might need to do some factoring. Okay, so again, when you look at these, there may not always be like a clear-cut way to get started. We might have to think, are there identities to start with, or maybe there's an algebraic step. Okay, we have to really think about all the math tools that we have up to this point. Okay, and so far that's been working with fractions, the identities that I'll provide, and then now possibly factoring. So why factoring? What am I seeing up here that tells me that I might be able to factor? Well, this term cosine of x minus cosine x times sine squared of x, both of these terms have a cosine of x, and thus we can factor that away from each term. So if I factor out a cosine of x, that makes this 1 minus sine squared of x. Now, that's a quick check. Anytime we factor, right? And this is just the greatest common factor. Okay? All I'm doing is pulling away what is the same amongst both terms. In this case, that's a cosine of x. So I'm taking it away, and then basically I'm dividing both those terms by cosine of x. Cosine times cosine is 1. Cosine of x times sine squared of x is just sine squared of x. And it's a really easy check to see if you distribute this cosine of x, does it match with where you started? Okay, and it absolutely does. Another kind of comparison here, this would be the same thing as if we had like 2 minus 2x, where the 2's are essentially the cosines in this problem, right? Both of these terms have a 2 that I could then factor away, making that the same as 2 times 1 minus x. Okay, so same idea as what we've already done with factoring, but now I'm just factoring out the cosine of x. All right, so the next thing, anytime we see these squared terms, and I kind of mentioned this on the last one, I'm probably thinking I need to use one of these Pythagorean identities. Now, these Pythagorean identities can be manipulated, meaning I can subtract cosine squared or subtract sine squared of x, okay, and get different forms of these identities. So I'm looking at this sine squared plus cosine squared equals 1, and it doesn't directly work for where we're at, but I'm wondering if I subtract one of those terms over, maybe I'll find a way to put that identity to use. So sine squared of x plus cosine squared of x equals 1. Well, I'm looking at this, and I have 1 minus sine squared. If I subtract sine squared of x from this Pythagorean identity, doesn't that get that to match up exactly with where that's at? It does. So we're going to take this Pythagorean identity, and I'm going to subtract sine squared of x, making it 1 minus sine squared of x. And now, those two things are the exact same. And now that they're the exact same, I can replace it with what it equals, which is cosine squared of x. So 1 minus sine squared of x does equal cosine squared of x. And so now this identity can be rewritten as cosine of x times cosine squared of x, because of our work with that Pythagorean identity. Well, cosine of x times cosine squared of x, that's just cosine of x times itself 3 times, which makes this cosine cubed of x. And thus, we have just verified that cosine of x minus cosine of x times sine squared of x does equal cosine cubed of x. All right, questions here, because there is some algebra steps here that are a little bit different. Go ahead.
Do we need to write out
So for those of you watching online, you're going to take this same identity, or this identity from checkpoint 3, and work to verify it. Should be a similar amount of steps, so go ahead and pause the video and work through it. Here's our next identity. So start to use some identity. So right now, when I look at 1 plus sine of theta over cosine of theta, maybe if I get sine over cosine, I can get that to be tangent, but I got to do something with that fraction. I can't just call this 1 plus tangent of theta. Okay. Manipulate the right side sometimes. Just kind of throwing that out there. One thing that this does kind of bring us a reminder of, though, is how fractions work. When I have 1 plus sine of theta and all of that's being divided by cosine of theta, sine of theta, and then plus sine of theta divided by cosine of theta. Okay, so that's just basically us undoing us adding fractions, right? If I have a common denominator, cosine of theta in this case, and I have 1 plus sine fractions there. Well, now I'm like, hey, 1 over cosine of theta, that's a reciprocal identity, 1 over cosine of theta plus tangent of theta, and that identity is verified. Okay. Not much to it. But again, we have to recognize how that fraction part finish it. So real quick, go ahead and take this checkpoint 4, work through that. I'm going to change this time to be like 1 minute. It shouldn't be that long. Okay, 1 minute and 30 seconds. If you're watching at home, pause the video, work through checkpoint 4. This last identity is just going to go into your notes. Okay, we'll practice this one. Here in just a minute. I want to just point out one kind of mistake that would be very common that a lot of you might be tempted to do, because we just worked on ones where we had in our now a lot of you might be tempted to do the same thing with this cosine of x divided by 1 plus sine of x, and say that that is equal to cosine of x over 1 plus cosine of x over sine of x. Well, break apart this first fraction like we were able to on that previous example. Okay, so that's just making up math. Okay, that does not work here. So us breaking up these fractions isn't going to work. So what else? On getting that to happen first, and it's going to look really messy. So I'm noticing that one of my denominators is 1 plus sine of x, the other is cosine of x. So this is going to be a case where I need to multiply both fractions by the other's denominator. So this left fraction I'm going to multiply by cosine over cosine of x. Okay, and that's going to make this denominator 1 plus sine of x. Sorry, you can't really see that. 1 plus sine of x times cosine of x. Over cosine of x. And I'm going to multiply it by the other term that's missing, which is that 1 plus sine of x. So this whole fraction is going to get multiplied by 1 plus sine of x over 1 plus sine of x. sine of x times 1 plus sine of x. So let's do a little bit of distributing, some simplifying. The numerator, I'm going to multiply cosine of x times cosine of x, making that cosine squared of x, over x. Okay, so that's just me simplifying this left side. This right fraction, we have 1 plus sine of x times another 1 plus sine of x. And for that, we need to completely FOIL plus sine of x to get sine of x. I'm going to do another 1 times sine of x, so another sine of x. And then the last term is sine of x times another sine squared of x. So that is just me doing the FOILing of 1 plus sine of x times another 1 plus sine of x. The denominator is the exact. So it feels like we created more of a mess, and it feels like we're really far away from getting it to be 2 secant of x. However, we have some simplifying things that we can do here. So I'm going to do 2 things next. I'm just going to rearrange the sine squared. I'm going to also add these sine of x's together. So after adding these fractions, we get cosine squared of x plus sine squared of x plus 1 and then plus 2 sine of x. So the main thing I did there was just add my numerators. Since I had a common denominator, I did rearrange to make the cosine squared and sine squareds next to each other. And then I combined the sine of x's to make that 2 sine of x. Pythagorean identity. So this cosine squared plus sine squared is now equal to 1, making this 1 plus 1 plus 2 sine of x over the common denominator of cosine of x, 1 plus sine of x. Two sine of x over cosine of x, 1 plus sine of x. And then in my numerator, is there some number or some term that shows up in both of those terms? A 2. So I can factor sine of x times 1 plus sine of x. And by doing that, the 1 plus sine of x's divide out. And so now where 1 over cosine of x is secant. And so now that brings us to 2 secant of x. Like I said, this last one, we really stepped it up a notch in terms of the algebra and identities involved. Okay, after that we do have a few more we'll work through, but that's it for today. No homework.